Today we're going to be talking about slope fields. And slope fields are kind of graphs of differential equations, kind of. It kind of tells us what the slopes at each one of the points are of a differential equation. And it also tells us what the graph could look like if we can't solve that differential equation. Okay, so the differential equation gives us a slope at any point xy. We already know that. So let's solve this differential equation. So separation of variables. Okay, what I'm going to do is I'm going to integrate both sides. When I integrate the left side, we get y. What function's derivative is cosine? That's sine. Now plus c. We don't have an initial condition. We don't have an xy point to plug in, so we have all these different possibilities for c. We have just regular old sine of x if c is 0. We have the sine of x plus 2. Y equals the sine of x minus 3. Now think about what this plus 2 and the minus 3 do. The plus 2, that's going to be a shift up of 2. It's going to be a shift down of 3. So an example of all the solutions to our differential equation is graphed below. Okay? But again, a differential equation gives us the slopes at each one of the points. So how we get a slope field. Okay, now that we know what the actual graph does look like, let's look and see what a slope field, how a slope field looks. Okay, you don't have to write down this first paragraph. Let me just talk about it real quick. So the information from a differential equation can be used to draw a small piece of linearization, or the slope of the tangent line, at that point. So we're going to be picking points along our interval and getting an idea of what the slope of the tangent line looks like. And that approximates in a solution to our curve. Repeating that process at many points yields what we call a slope field. And this here, this is an example of a slope field. So let's get an idea of how we get that slope field. Let's plug in a bunch of points. Well, our window goes from negative 2 pi to 2 pi. So let's get in a bunch of values here. So pick values, x values that are easy for you to plug in. I only need x values because cosine's only in terms of x. Okay, now we get an idea of what the slope is. So dy dx equals the cosine of negative 2 pi. So I evaluate the cosine of negative 2 pi, which is equal to 1. So at negative 2 pi, my slope should hopefully be 1. Which you notice, for all our values of 2 pi, our slope is a positive 1. So that's what those little dashes are. When I plug in 3 pi over 2, the cosine, I apologize, negative 3 pi over 2. When I plug that in, we get 0. Okay, notice how all the slopes at negative 3 pi over 2 are 0. When I plug in negative pi, we get negative 1. All of these slopes here are negative 1. When I plug in pi over 2, we get 0. Again, our slopes are 0. So then when I plug in 0, we get the cosine of 0 is 1. All our slopes are 1. Pi over 2 is 0 again. Pi is negative 1. 0 when we get to 3 pi over 2. And 2 pi, we get to 1. Now say we had an initial condition. We solved this on the last screen. So say I knew the point 0, 1 was on our curve. We can then get an idea of what our curve looks like. So this point is on our curve. Well, I know I'm sloping positive. I go to 0, then I slope negative. We go to 0, then we slope positive again. Going the other direction, we go negative. So that's what one of our curves looks like. Well, what is that? That's a sine curve. That goes back to what we were doing on the last screen, what I showed you guys on the last screen, and that is actually this curve that I'm highlighting right now. Okay? So you can get an idea of what your curve looks like of a differential equation, even if you can't solve it. Now, I used one as an example that we could solve just so you guys could get an idea and hopefully put some of the pieces together. Okay, we can't solve this differential equation with any of the methods that we have because we can't separate those variables. I can't get the 2y on one side. Okay, so what we're going to do is we are going to use our slope fields to get an idea of what the curve looks like at the point 0, 1. Okay, so we have 4 by 3, so we have 12 points we're going to try and find our slope at. So we have to come up with an x point, a y point, and what our slope is. dy dx. Okay, so organize. I'm going to start at the left. I'm going to start with negative 1, negative 1. Then we go negative 1, 0, negative 1, 1, and negative 1, and 2. So let's get each one of these slopes. So I plug in negative 1 for x, plug in negative 1 for y. When I plug those in, we get the value of 1. So at the point negative 1, 1, you draw a little line that has a slope of approximately 1. And these are just approximations. When I plug in negative 1 and 0, we get negative 1. So I have a slope that's sloping negative. When I plug in negative 1 and 1, we get negative 3. So a little bit steeper. Try and make sure you can tell a difference. When I plug in negative 1 and 2, we get negative 5. So even steeper. Okay. Now let's move to, I think about it as the next line. So for each one of these, x is 0, but y has changing values. Okay, I'm going to do these in a different color. So I plug in 0, and I plug in negative 1. That means we get a positive 2. So at 0, negative 1, we get a positive 2. Now a positive 1 slope kind of looks like a 45-degree angle, so I'm going to do it a little bit steeper. Try to make it steeper. When I plug in 0, 0, we get 0. So a straight horizontal line. When I plug in 0 and 1, we get negative 2. So a line that's sloping about negative 2. So not as steep as this one. And then I plug in negative 4. A little bit more steeper, but not as steep as our negative 5. And these are, again, are just approximations. You just need to make sure you're going the correct direction for your sloping lines. Okay. Lastly, let's do our last column where x is equal to 1, negative 1. That value is going to be 3. So fairly steep line. When I plug in 1 and 0, we get 1. So I think of that like a 45-degree angle. 1 and 1, we get a -1. And then when I plug in 1 and 2, we get a -3. Okay, so that's what our slope fields look like. Okay, now since we can't solve this equation, what we need to do is we need to get an idea of what the graph looks like when it goes through the point 0, 1. So this point is on my graph. So my slope is negative there, so I need to be decreasing. I come from the left, I'm decreasing to the left because all those slopes are negative. Still decreasing, but then I'm decreasing. When I come down here, I change back to increasing. And I might change somewhere in here, because this slope here is a positive one. So I change from decreasing where slopes are negative around to increasing where our slopes are positive. It's kind of an awkward example to try and draw it in. I kind of added in this point at the last minute, but hopefully you guys get an idea of what is going on there. Okay, that's it for today. Please make sure your lesson summary is submitted on time.